What we saw in the last video is called a gate. We saw a NOT gate, and it's usually represented this way with this symbol. When this is the input, this is the output, and this will be the NOT gate. Okay, but this gate inside is the what we saw that here we have a resistor, and this will be the output. Huh? A NOT gate is an electrical circuit, and computers are made of millions and millions of these gates. I want to show you an example of another gate so you can understand a little better how this works. For example, we're going to build an AND gate. The AND gate has two inputs and one output. Remember the AND truth table is this. I need one more. This will be the input one, input 2, and this will be the output. It will receive a 0 and a 0. We'll have a 0 as output, and I'm gonna draw all the truth table. So in the case of AND, we only have a 1 if both signals are 1. So how can we, for building that, we are using another gate, another Boolean operation. It's called NAND. The NAND is the inverse of the AND. So for example, we have this. This will be the AND output will be this, and the NAND output will be the same but reverse. And this is NAND. This is NAND. Okay, how can build that using switches and a resistor and voltages? So we have here the 5 volts line. We have this, a resistance, and in this case we have two switches. Here, round, and our output will be here. This is the output. This will be input 1, and this will be input 2. Input 1 and input 2. And what happens? Imagine that we receive a 0 and a 0. So both switches are opened. So the output will be at 5 volts because remember that we have 5 volts here unless all the switches are closed. The current, if the current can't flow to the ground, this will be, we will have 5 volts here. So 0, 0, 5 volts, and this will be a 1. So this is this part of the truth table. If we open a single switch, the current won't be able to have this closed, but this is open. So the current won't be able to flow, and we have a 5 volts here and still a 1. So this is this case, and the same if we open the second one. We open the second one, this will be closed, this will be open, but still the current can't flow because it can't jump over here. Okay, you need the switch to be on. So the last case is when both of the signals are 1, then this switch is closed, this switch is closed, current can flow here, and we have 0 volts, and this will be a 0, this case. Okay, we have seen that before. So this will be a NAND gate. The NAND gate is usually drawn this way. This is one input, and the output. This will be an AND gate. And how can we build an AND gate from an AND gate? Well, we simply add a NOT here, and then we will have an AND output. Okay, to add an AND here, to add the NOT gate here, what we will do, I want to erase this. We'll combine this NAND circuit with the NOT circuit that we seen in the last video. So we have this, the gate, ground, and the output, and this will be the output of our AND gate. Okay, so we will need 3 switches to build an AND gate. This is how the computer will be made internally. Okay, we usually don't use AND operations inside a computer because all the logic uh, of a computer could be made with NAND, NOT, and OR. But this is only an example for you to see how a computer gate can be built.